Okay, please try the questions before you go through the solutions. Okay, it says work out the percentage of drivers who were first time users. Now, percentage, not angle, they want you to work out the percentage. So if we look at the percentages, you've got 35%, 30%, 20%, and when you add those together it gives you 85%. Percentages have to add up to 100, so 100 subtract off your 85 to give you 15%. Okay, 200 drivers are surveyed. How many of these drivers use the petrol station less than 1 week ago? So less than 1 week ago is 30%, so we want 30% of 200. 10%, remember, to find 10% you divide by 10, so drop a naught. 10% is 20, so 30% you're going to have to times that by 3. So times this side by 3, 60. Okay. There are 8 discs in a bag, so 8's important. 4 are red, so the probability of getting red is going to be 4 out of 8. 3 are blue, so 3 out of 8. And 1 is green, so 1 out of 8. On the probability scale, mark with an arrow the probability that it will take a red disc. Red is 4 over 8. We have 1, 2, 3, 4, 5, 6, 7, 8 dashes. So we're going to go for the fourth one. 1, 2, 3, 4 for red. Okay. On the probability scale, mark with an arrow the probability he will take green. Green is 1 out of 8, so we go to the first one. And the last one, the probability that he will take a yellow disc. There are no yellow discs in the bag, so that's got to be impossible, so 0. Okay, question 3. A key question that you must learn how to do. Calculate an estimate of the mean. Mean, and it's from a table, so we use sigma fx divided by sigma f. Remember, sigma just means total of your fx column divided by total of your f column. The first thing we need to do, we've got a grouped class width here, so we need to find the midpoint. That will be your x column. So middle of 0 and 10 is 5. If you're not sure, add them together. 0 plus 10 gives you 10, divided by 2 gives you 5. But I think for these groups it's fairly easy to see where the middle is. 15, 25, 35 and 45. Then your last column needs to be your fx column, so you multiply your frequency and your f column to give you values of 30, 150, 500, 280 and 270. Now you need to be careful which columns you add. You need to add your frequency column, which is 50, and you need to add your fx column, which is 1230. So when you do your division, 1230 divided by 50, it gives you an answer of 24.6. Question 5. Okay, you've got a stem and leaf diagram. Remember, if you are asked to draw a stem and leaf diagram, make sure you always have a key. Write down the height of the tallest player. Tallest player is this one, so that is 194, not 4. Write down the range. Range is biggest take smallest. So your biggest was 194, your smallest was 177, so 194, 177. Subtract those two away to give you an answer of 17. Write down the median height. Now, median is the middle piece of data. So to find the position of the middle piece of data, you do n plus 1 and divide it by 2. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data, so it's going to be 10 plus 1 divided by 2, which means you're looking for the fifth point fifth, but there is no fifth point fifth, so you look for the fifth and sixth piece of data. So we count along. 1, 2, 3, 4, 5, 6. So it's going to be halfway between there. They're both the same, so it's going to be 186. Another player of height 188 joins a squad. Explain why the median height will not change. Well, if we put on 188, it would go on the end here. Okay? That means we now have 11 pieces of data. Plus 1 divided by 2, we would be looking for the sixth piece of data. The sixth piece of data is still 186, regardless of whether you have the extra 188. Okay, Paul has two six-sided dice. He knows that one is fair and one is biased. Describe how he could find out which is the biased dice. Right, well, he's got to work out, do an experiment or a trial. Okay, and he needs to roll the dice a fair amount of times. I would go for 100 to 200 times. Okay, he needs to record, so 1 mark for saying an experiment, 1 mark for giving a sensible number of times. Record his findings. Okay, another mark. And the final mark for saying compare his findings, which is relative frequency. Compare his relative frequency to the actual expected probability. For example, you would expect to get 6, the probability of getting a 6 to be 1/6. So cancel it down and say, do you get 1/6 when you are near it when you do the experiment? Question 7. Sam and Pat are playing a game of dice. Sam plays the game using a biased dice. Biased, remember, means it's unfair. The probability that he throws a 6 is 0.1. Write down the probability he does not throw a 6. Remember, probabilities have got to total up to 1, so 1 subtract your 0.1 gives you 0.9. Sam throws his dice 120 times. Work out an estimate. Okay, your expected, this is a wee formula that you need to have learnt, is your probability times by your chances. Probability of getting a 6 is 0.1. He's rolling it 120 times, so that's 120 chances. So multiplying that out, either with a calculator or without, it should get you 12. Without a calculator, remember, take the decimal point out. So 1 times 120 gives you 120. You'd 1 decimal in the question, so 1 in the answer, 12.0. Pat plays the game using a fair dice. She throws the fair dice 120 times. Is she likely to throw more 6s than Sam? Well, a fair dice, to get a 6, probability of getting a 6 would be 1 out of 6. So you're trying to find 1/6 of 120. 120 divided by 6 gives you 20. So you would expect to get a 6 20 times. This one's only getting it 12 times, so you would expect her to get it more times, but you need to show or give a reason for your answer. Okay, question 8 then, you have a scatter graph. So we'll go and plot each point. 15 with 77. Okay, with little x's. 22 with 72. 39 with 59. 22 with 69. 8 with 82. 30 with 64. And 11 with 79. Okay. It then asks you over the page for the strength and type of correlation. Now, I would say that this is weak. They're fairly scattered. There's a few points that aren't lying on directly on your line of best fit where you draw it, and it's negative. Remember, the line is sloping down the way, so when it's sloping down, it's negative correlation. If it's sloping up, it's positive correlation. If the points are all over the place with no real pattern to them, it's zero correlation. Draw a line of best fit then. So we want it going generally in that direction. And it says use your line of best fit to estimate the life expectancy whose birth rate is 16. So you would, again, I would draw in where I'm getting my data from. So I would draw in these lines. So I go to 16, draw in my line, bring it across. That works out to be in the region of 76. So anything, would take anything from about 72 up to about 78, depending on your line of best fit. In the next part, why might it not be reliable to use the line of best fit to estimate life expectancy for Niger, whose birth rate is 50 births per people? Now, your graph doesn't go up as high as 50 births per people, so you need to say that there's no data for 50 births per million or per 1,000 people. The trend may change.